My lords, ladies and gentlemen, it's a great pleasure to welcome you here this evening to the Academy for this, our flagship lecture. Before I introduce our speaker, I'd like to take this opportunity to thank our forum partners whose continued support enables us to hold this and other Academy flagship events. Our thanks go to BAE Systems, IBM, Kinetic, and the Weir Group. Thank you all very much. The Hinton Lecture honours the late Lord Hinton of Bankside, the first president of the Academy. Lord Hinton was one of the 20th century's most eminent engineers, making an enormous contribution to the technology of energy generation and, in later life, to politics as an active member of the House of Lords. Lord Hinton supervised the construction of the UK's very first nuclear power station in the 1950s. And our speaker tonight brings us up to the present day and future nuclear with his hard-fought legacy of Hinkley C under construction right now. The Hinton Lecture addresses some of the greatest engineering challenges faced by the profession. And tonight's speaker, Academy Fellow Vincent de Rivaz, former Chief Executive Officer of EDF Energy, will explore the changing face of the UK's energy market and what's next for the industry, including how we can embrace a lower carbon future and encourage the next generation of engineers. Reflecting on a career spanning 4 decades at the forefront of the energy sector, Vincent de Rivaz has overseen the outstanding safety and operational performance of the existing UK nuclear fleet. Through the groundbreaking Hinkley Point C project in Somerset and the wider partnership with CGN, he's led the way for the UK's new nuclear programme. And this has not, of course, been without controversy, which, of course, is almost inevitable with projects of such a huge scale and importance. Vincent joined EDF in 1977. He managed the Far East region of the International Division, placing EDF as a major player in China. Later on, he worked as deputy head of EDF's International Division in charge of large projects abroad before becoming deputy chief financial officer and CEO in 2002. Vincent is a hydroelectric engineer who in 2009 was made Chevalier de la Légion d'Honneur and an honorary commander of the British Empire in 2012. Delighted to invite Vincent de Rivaz to give this year's Hinton Lecture, The Nature of Engineering in a Fast-Changing World. Thank you.
My lords, ladies and gentlemen, good evening. Thank you, Dame Anne, for your kind introduction. I am pleased and humbled to be here with you all this evening. It's really a great honor to be invited to give this year's Hinton Lecture at the Royal Academy of Engineering in the front of such a distinguished audience. And I'm very conscious that this is named for the first president of the Academy, the father of the UK nuclear power industry and the first chairman of CEGB. We owe a great deal to the generations before us and to those who will succeed us. The UK's National Academy plays a vital role in bringing together people from across the profession to advance and promote excellence in engineering across the generations. And I was delighted to be elected a Fellow of the Royal Academy of Engineering in 2015. And I would like to pay tribute for all that they do for the sector and the wider society. As you know, I have recently stepped down from EDF Energy after 16 years at the helm as CEO and a 40-year-long career with the EDF Group. And before my departure, I had a moving, at the same time, uplifting experience of saying goodbye, visiting 20 different sites and power stations all over the country, including West Burton, whose coal station was the last winner of the CGB's Hinton Award for good housekeeping, and who is today also home for a new 1,500 megawatt CCGT and one of the largest in Europe battery storage project. And it was emotional for me to say goodbye to all the people who have contributed to the success of the company, to say goodbye to so many talented engineers. And my farewell encompassed three messages. One, thanking people for all that they have done and for their support. And two, celebrating with pride our collective achievements. And three, confidence in the future. The best is yet to come, with, for example, the construction of EDF Energy new nuclear power station at Hinkley Point C, which is well on track. And this is my theme today, the future, and what it takes to make it a better future. So I would like to use this evening lecture to share my thoughts with you on the nature of engineering in a fast-changing world. But first, let us reflect for a moment on the word engineer. What are its origins? What does it mean, actually? The word engineer can be traced back to the Latin word ingeniator, which is derived from the Latin words ingeniare, to contrive, devise, and ingenium, cleverness. What it is to be an engineer, the idea of creating things, devising things, and being inventive are all enshrined in the word itself. Queen Elizabeth has described engineering as about using science to find creative, practical solutions. And she added, it is a noble profession. I was personally encouraged to become an engineer by my father, and my grandfather was an engineer in a different time, in a different world. And even as far as back as the 1800s, there were engineers in the de Rivaz family. One of my ancestors was Swiss inventor, François-Isaac de Rivaz, who invented the de Rivaz engine, potentially the world's first internal combustion engine. My ancestor, by the way, was both a politician and an engineer. So inspired by a strong family connection to the sector, I embarked on a career in engineering. I was born in Paris, but I consider myself to be a Savoyard. Savoy, a neighbor of Switzerland and Italy, became part of France in 1860, after having been an independent state for 1,000 years. It's a beautiful region of high peaks and running rivers, where the natural resources lend themselves perfectly to the development of hydropower, a resource that can be easily tapped into. There is a long industrial tradition in Savoie, and the region is at the very heart of hydropower. And this inspired me. I trained as an hydroelectricity engineer in the neighboring city of Grenoble. And today, like many parts of Europe, including UK, the Savoie has to reinvent itself in the context of huge economic and social transformation we are all facing, largely triggered by the new technological transformation. And I will speak about that tonight. So I started in EDF building dams and hydropower stations on rivers across Asia, Africa, and France. My career encompassed working with highly talented engineers in France, in China, and in Britain. And then another low-carbon electricity source, nuclear, became more prominent in my more recent years as a CEO at EDF Energy. And I have stayed true to my roots. It is an exciting time to be an engineer. Our world is changing fast with new technologies and new opportunities. In my farewell speech on the 19th of October, I talked about the future of the energy industry. I talked about EDF Energy in 2033, in 16 years from now, a company transformed to address future energy challenges. And engineering is at the heart of this transformation. And engineers are central in addressing the threefold challenge of the energy business. We have a common enemy in climate change. We have a common goal, security of supply. And we have a common duty to deliver reliable, low-carbon electricity in a way which is affordable. And to address this challenge, engineers and society must work hand in glove. And the ever-changing digital and interconnected world needs engineers. The digital transformation is an engineering transformation. In the future, the UK will have a smarter, more decentralized system of generation and consumption. It needs a mix of centralized and decentralized electricity generation, which works for everyone, for the many, not the few. Smart meters will have been rolled out. Electric vehicles and connected homes will have advanced even more. Local generation will play a bigger role. The network will cope with two-way flows. A centralized generation, low-carbon nuclear, will, in this context, remain essential. And with new plants in construction, plants being closed, decommissioning will also have to come to the fore. And artificial intelligence will play a key role. Artificial intelligence techniques are developing very fast. The latest research has shown that they can surpass the capabilities of people in solving problems one thought to be uniquely human. Advances in technology, communications, and data handling are setting the stage for staggering global impact in the coming years. Just look at the progress made in recent years. Virtual assistants, we've leveraged deep learning to understand user intent and respond with relevant information, exemplified by products like Amazon Echo. They can book appointments, share information amongst a group of people, and answer questions on a specific topic. And EDF Energy is already embracing this kind of artificial intelligence with an energy app for Amazon Eco launched last year, creating new ways for customers to engage with energy. Robotics is also a field that has already greatly benefited from artificial intelligence. Self-driving cars are expected to hit the market soon, whilst factories and supply chains can largely be automated. Energy distribution networks, energy production, and storage units could also be automated. But what will be the impact of all these for society? What is the impact of automation on jobs? Where are the ethical issues? Are we ready with innovative regulation of innovation? Artificial intelligence cannot be a substitute for the intelligence of the hearts and minds of real people. Looking more broadly at the engineering sector, what will be the future makeup and demographic of Royal Academy of Engineering Fellows in 2033, for example? What will be the mix of disciplines? What will be this future? Like the electricity sector, I expect the themes of decentralization, democratization, and digital will have changed the makeup and view of engineering. I think the fellows of the future will be drawn from many different disciplines, including areas we don't even know about yet. Bringing together intelligence with the needs of society. There are many areas where engineering has already a great impact. This must be sustained and accelerated as the nature of engineering and society changes and evolves. Encouraging new way of thinking is essential. EDF Energy, for example, has created Blue Lab, its innovative accelerator, to do just this, to diffuse a culture of innovation and entrepreneurship within EDF Energy, to anticipate customer needs and build links with the startup community and others to make ideas a reality. For example, EDF Energy support for Startup House, one of the winners of the EDF Energy Pulse Awards 2016 and the winner of the EDF Group Pulse Awards 2017, is a great example of a new technology being a force for good. EDF Energy has worked with them very closely on technical and customers' trials for their connected home system. Another example of fresh thinking. EDF Energy is working in partnership with Innovate UK in an innovation challenge to look for new and innovative solutions to inspect and monitor nuclear power and offshore wind farms in a safe, fast, cost-effective, and accurate way, harnessing new ideas, new approaches. Engineers of today and tomorrow will need to keep learning and to keep adapting, to keep us to speed in the face of fast-moving technologies. I have spent 40 years within just one parent company. It is no longer the way of the world. Today's and tomorrow's engineers need to keep building on their expertise so they can be agile and be prepared to work for a range of different organizations through their career in order to provide the skills society needs, to be resilient and not fragile. The UK will need an extra 1.8 million engineers in the coming decade. There is more to be done to address the skills gap. Diversity and inclusion are key to securing the pipeline of talents needed today and in the future. We won't succeed if we apply the same methods with the same-minded people. Diversity and inclusion foster innovation by broadening perspectives and ideas. Diversity and inclusion are also key for productivity. Engineering needs to involve really thinking about how things will be implemented practically. At Hinkley Point C, the teams are making this concept a reality. The project must strike the right balance on safety, quality, time, and cost. This project is the quintessence of an industrial project. And it is also a digital project. It will be built virtually before it is built physically. If they are isolated, design engineers working on nuclear can have the tendency to overemphasize the safety margins, which can create difficulties for the construction teams to build it right first time. Rework can then cause delay, compromise safety, and cause added cost. Close collaboration on this project between the teams in Paris, in Bristol, Somerset, is enabling engineers to develop civil solutions that involve up to 20% less steel and concrete compared to initial estimates. These, in turn, are easier to get right, easier to build to time, with a long-term benefit to safety and are less costly overall. Simplicity and efficiency, not overcomplication. This is key for productivity. A diverse and inclusive workforce will help bring these ideas to the fore. Diversity and inclusion are also important for a happy workforce. The links between management, engineers, and the staff on the ground is essential. People need to feel motivated, feel part of a team, and feel their work matters. Pride is the biggest source of productivity. The role of line management is essential. The world of engineering must be connected to the world on the ground. The best team is always greater than the sum of its parts, and sharing knowledge and being inclusive is the key. And a diverse team is also better than one made up of clones. Hinkley Point C is industrial strategy in action. This is a transformational project for the Southwest and beyond. 64% of the construction value will be spent in Britain. And the project is making an impact in every region in Britain, boosting regional economies and supply chains. The engineers working on this project are part of the solution to keep the fabric of society together. A more inclusive society to tap the richness of diversity. And EDF Energy is tackling these challenges head-on. For example, the Pretty Curious program was launched in 2015 to address the issue of underrepresentation of women in science, technology, engineering, and math careers. It has used digital channels to highlight the breadth and of opportunities and some of the more unexpected careers available by using inspirational and successful female role models working in STEM, and provided hands-on, innovative experiences through workshop studio events, allowing girls to experiment STEM in a new light. In 2015, we trialed hands-on events in London, Bristol, and Glasgow. In 2016, this expanded to reach over 1,000 girls at events in Bristol, Ipswich, Croydon, and Edinburgh. And this year, the business is on course to again engage well over 1,000 girls at events in Harrogate, Maidstone, and etc. EDF Energy has a number of other education initiatives, including the award-winning Pod Schools program. It is now the largest program of this type, with over 20,000 registered schools across the UK. And the Inspire program, to help students understand STEM and prepare them to embrace the career opportunities that the construction of Hinkley Point C will bring. Inspire has engaged with over 110,000 students in over 200 education institutions across the Southwest since it began. And of course, EDF Energy's 7 visitor centers across the UK will attract thousands of visitors each year. We celebrate the 522,000 in October, in just 5 years, including many school children and students. The visitor centers, close to each of EDF Energy's industrial sites, including all our nuclear stations, are a vivid illustration that bring together the world of engineering and society at large is a win-win. Engineers are proud of being recognized as a force for good, and society feels respected and able to hold engineers to account. It is EDF Energy's 3 T's in action: trust, transparency, teamwork. With these efforts and more, EDF Energy is making progress on attracting more women. For 2017, 35% of EDF Energy new STEM apprentices will be female, compared with 22% in 2016 and just over 8% in the previous year. It is great to see a few young engineers from EDF Energy here tonight in the audience. There is so much up and coming, diverse talent at EDF Energy and beyond. But the business, the sector, and society as a whole has much more to do in this field. And now to collaboration. Collaboration is key to a successful future. We need engineers to build bridges with people, not just for people. Building the relationships between the UK, France, and China, for instance, has helped secure the future of Hinkley Point C and other nuclear new builds projects. Today's and tomorrow's engineers need to build bridges with business, academics, industry, and the wider global community, without forgetting the most in need. EDF Energy is already encouraging social action to help people, essentially young people, play an active role in their communities. And we are proud to support the Prince of Wales' Step Up to Serve and I Will campaign through its partnership with National Citizen Service. Alongside the POD, the Big Energy Project, apprentice development, early careers recruitment, and wider employee volunteering. It is I Will Week this week, celebrating young people who lead social action. And this kind of action is at the heart of any successful and sustainable industrial strategy. And we see collaboration happening in the Southwest as Hinkley Point C moves forward. And I see similar opportunity in the east of England as we progress the follow-on project as at Sizewell and Bradwell. Looking globally, globalization is an opportunity to share ideas, expertise, culture. We must take it as an opportunity in insisting on the fact that without culture, no economy can flourish. The engineering world must participate in that, not in isolation from those challenges. The culture of engineering is to be problem-solving, part of the solution, not part of the problem. And finally, before I conclude, to the digital revolution and the need for a responsible approach. Digital and its transformation impact are everywhere. For EDF Energy, digital transformation means improving the way it delivers power to customers, but also empowering and respecting them. Digital must not be a wedge between the company and its customers, but the recipe for a new partnership based on trust, transparency, and teamwork. Some say the digital world is flat and accessible, and they celebrate that. But it must not flatten personalities and depersonalize relationships. Digital must help to be responsible and accountable, and never the opposite. Becoming an industrial digital company means combining the great industrial heritage with the best of the digital world, not replacing it. We all have a responsibility to the younger generation to ensure society gets the digital transformation right. It is vital to place the human at the heart of new technologies. And we must face the challenges of cybersecurity for our democracies and for our ability to live together as free men and women with due respect for privacy and freedom. Here again, engineering must be and can be a force for good. Enabling the digital revolution is one big responsibility. Understanding its transformative impact on our society as a whole is an even greater one for us all. Therefore, I think it's fair to say that it is truly an exciting time to be an engineer. A fast-paced environment with emerging technologies and the chance to make real impact on society. This sector is a fascinating place to be and to build a career. But times are changing, and so is the nature of engineering. And to succeed in this new world, as engineers, we must be innovative, be strong communicators, and be ready and willing to adapt. We must explore new ways of thinking. We must embrace diversity and inclusion to open our minds to new ideas, ways of working, and to new possibilities. And we must expand our horizons, build new relationships. Hinkley Point C is a symbolic example of the future opportunities for the engineering community brought about by collaboration. And we must, of course, ensure we embrace this new world, this digital transformation in a responsible way. As we move forward and the world moves on, we must ensure society continues to respect engineers. Engineers cannot operate in a silo. They require the wider community and society to embrace modernity and change. But engineers must also play their part in educating society about the role they play in improving lives for all, to ensure engineers and engineering team remain at the heart of our society and the voice of engineers are heard. And to conclude, let me say again how humbled I am to be in front of this audience tonight. Honored to have been invited to give this Hinton Lecture. And I would like simply to congratulate the Royal Academy of Engineering for all it does. And I wish to tell them that the best is yet to come. And can be ensured that my successor and his team, some of them are there tonight, are really looking forward to engaging with you on this important, exciting journey for our societies. Thank you very much.
I hope you're willing to take some questions, and we'll do it from the chairs. Well, Vincent, thank you for a wide-ranging and inspiring lecture. And many of the things that you talked about really resonate with what this academy is striving to do, particularly giving engineering a visible position in society and a voice, as well, of course, as you are with EDF, encouraging a diverse group of young people in increasing numbers to think of engineering as a career. I'm sure your words will have generated lots of questions from those in the audience. If you'd like to ask Vincent a question, would you put your hands up and then wait until the microphone comes to you? Questions? Yes? On the side at the back there. And could you say your name and where you come from as you start your question, please?
Of course. I'm Ben Britton from Imperial College in London. Thank you very much for your talk. You commented that engineers must bring society with us, as well as we must come along with society. I guess as an emerging academic engineer, what would be the most impactful way that I could encourage my colleagues and students in particular to make that change happen?
I don't think there is one, as always in this complex situation, one single bullet which fixes it all. It's, and I think it's exactly what the Royal Academy is doing, a constant effort, bringing together many initiatives. It's not a magic wand. What is important, as always, if you want to be successful in a big transformation, a big adaptation, is to have a vision. Mm-hmm. And I think the vision, you have it, and we share it. And sort of being a practical idealist. We need a vision. At the same time, it's my view, we have to have the ability to make the first steps and to make it happen. And then other steps will follow. Mm-hmm. So let us be idealists and at the same time very practical.
I think while academies and big companies can do a lot and are doing a lot, I think individual engineers have a role to play as well. Yeah. Just communicating what they're doing to people around them. Yeah. And not just around the technical, but actually what your job means, what you're actually delivering for society. I think sometimes we don't talk enough about what we as individuals are actually doing. You mentioned what you do in a party and people's eyes roll. You tend not to say, but actually it's what's keeping the lights on or whatever it is that you're working on. Yeah. So I think as individuals we have roles to play, but of course as a group we can have so much more impact working together.
And
very
being,
interesting point.
And being enthused, being
yes.
joyful, being positive.
Yeah. We did a recent survey on workplace cultures where questions were asked of engineers, did they enjoy their job? And the results are just fantastic. I forgot, it's up over 75% of engineers really enjoy what they're doing, whereas Investor in People did a survey of the population as a whole, and 60% of people want to change their jobs. So, you know, we are in a marvelous profession, and we don't share it often enough. Yeah. More questions? Oh, lots. Okay, let's take one there.
Nicola Fauvel, EDF Energy. Vincent, from your 40 years of experience, what advice would you give to a hypothetical granddaughter to perpetuate the illustrious line of engineers in the de Rivaz family?
You know the answer, no?
I have my version.
I'm not sure. There are, as I said already, a kind of unique answer to your question. I mean, my experience is that you really need to work hard. It's a basic. And B, at least for a company like ours, working as a team player is absolutely critical. There is no real, in my view, if there is a kind of selfish, maverick, mercurial individual wanting to succeed alone, exit door. You are not welcome in a business like ours, because this business requires every day, given the nature of the process, the end-to-end process that we are dealing with, the complexity of things, people working as a team. So for me, it's absolutely fundamental. And as I have said a couple of times in my talk, there is no real possibility to have a real teamwork or a team working without two fundamental elements, which is transparency, sharing information, being honest when there is a difficulty, being honest, we are facing a problem. And there is no transparency if there is no trust. Well, people will be transparent if they don't trust each other. So for me, the three magic words, magic, I don't know if they're magic, but very important in our job. I think it applies elsewhere. Team, trust, transparency.
Okay.
And the rest will follow.
More questions? Well, we'll come to you next.
Tony Gillespie, a fellow of the Academy. I see from your biography you spent several years in charge of the finance division.
Yep.
And I wonder, this is a significant difference between European and British companies. What are your views on the importance of having engineers in charge of the finance of an engineering company?
Well, I was not in charge of the whole finance. I was in charge of a big part of it. The funding of the company, M&A, insurance, real estate, and a few other things. Well, I would say one thing which each time in my career, 40 years, I have moved from one job to the other. I have always been lucky to use what I have learned in my previous positions. So I'm not the kind of people swapping from one position to the other, starting from scratch. I've always tried to build from what I have learned in taking a new position. So when I become in charge of a big part of the finance division of the group, I think my engineering mindset helped me a lot. To understand some complex financial problems, and also to have the kind of method that we have learned at school and have applied in being engineers. So, what can I say? I think it's my theme of diversity and inclusion. It's very good, and it is a great chance that EDF gave me. I stayed in the same group, but I did a lot of diverse things. But it was also always inclusive. was not one thing and then totally different thing with silos. But I will not draw general lessons about engineer versus finance. I mean, we need both. And it's very important that engineers know the importance of finding the money and controlling the costs. Because there is no business otherwise. But the finance people in industrial company should never make the mistake to ignore what industrial company is all about. And for instance, playing with organizations because it's popular in the city is not a strategy. And at the same time, we need to have the investors happy with the money they put in the company, striking the right balance. So that's my message. I mean, and around the table of an executive committee, we need to have common language. And I said in my speech that, in my view, without a strong culture, there is no economy that can flourish. And for a company, it's the same. If there is not a strong culture in one company, it cannot flourish. So each company has to have its own culture based on its history and what it's doing. But it is, in a world where people are asking often who I am, where the question of identity is becoming, and sometimes used by the politicians in the wrong way, to divide, to create an entrenched position. My identity against the other one.
Thank you.
Identity is essential. Essential. And in our business, the identity is largely one of being able to deal with long term. And if I have to characterize EDF Energy, it's a business which is very much about long term, and at the same time, being very nimble, reactive, taking decisions every day in a very competitive environment.
Thank you. The lady here, please, and then I'll come to you afterwards, Alec.
Hello, good evening. Candida Whitmill from Penultimate Power UK. With your experience and knowledge of the energy landscape in the UK, Europe, indeed global, could you give us your opinion on small modular reactors and how they fit into the future energy?
So first of all, there are two sites which are ideal for small modular reactors in the UK. They are Esham and Hartlepool. They are ours. Just saying that. Point number two.
Why? Are you going to explain that?
Well, because the space, because the connection to the grid, because the position in the system.
Right.
And it leads me to the second point. We cannot develop small modular reactor only through, let's say, a technological or design angle. We need to find a market. And it is probably one of the reasons why this question has been, the future of SMR has always been great, but 20 years ago, 10 years ago, and still today, to find a market. And then the question of small is beautiful is not always true. The economy of scale remains in our industry very important. So if you go to something which is too small, we need to find a way that it remains cost effective. And sometimes projects which are called small modular are neither small, neither modular. Now, having said all that, we of course we are going to be involved, and there are colleagues in the room which have been working on it. It's a typical of an area where we need to work globally because the market is global. And again, we should not be driven only by the technology, but also by the market.
Thank you. Alec? And then we'll go down the back after that.
Alec Browse, I'm a fellow of this academy, and I'm one of the few engineers in Parliament. I've got a general observation that I've just learned about today I'd like you to comment on, and then I've got a difficult question for you. The observation has been made by 4 academics at Stanford and 1 at MIT that the cost of new ideas, the cost of research is increasing, and its productivity is going down, declining, they have observed, at a rate of 10% a year. Productivity is a very big subject here. They start with looking at Moore's observation back in the 60s about the productivity of microelectronics, and Moore's law is no longer being followed. We're seeing a decline in that. But they then spread it far more widely than that, you know, it is becoming more and more difficult and therefore more expensive to find the innovations that you need if you're going to increase productivity. It was just a new observation to me, and I noticed it because it is 4 very respectable names from Stanford and from MIT. This is a serious study. So I'd like you to comment on that. And then my question is that in this country, we're very worried about our productivity because it's lower than that of France and of Germany and of Italy and of various other places. You've worked in both places. What are we doing wrong? Why is our productivity lower than France's?
Yeah, I will certainly not answer in a sort of binary way about. I think productivity is the result of a lot of actions, and I think logically what is going to be published Monday about industrial strategy, which will be precisely a strategy to create the context for higher productivity, which implies a lot of things. Better infrastructure. If there is no transport infrastructure, there is an impact on productivity. Better skills. Etc., etc. But the productivity, it's about people. So how people, I have said in my speech, the single biggest factor of productivity is people which are motivated, engaged, respected, trained, developed. The culture of hire and fire, which has been often, too often, sort of magic wand, is a disaster. And we are not going to build the largest construction project in Europe, in Cleponcy. We are building it at the moment in the Somerset. It's progressing well. With a culture of hire and fire. We need absolutely to have people, and it is a 10-year project, which will be followed by others in Sizewell, in Bradwell, elsewhere. They have to be part of the project. That's, for me, absolutely fundamental. And 2, I have said it, I mean, the line managers, the organization of a large site, how to avoid people are idle, is part of the solution. And one of the reasons sometimes people are idle is when the engineering is not arriving the right time, when the qualified equipment are not arriving the right time, and people are just waiting. It has a big impact on the productivity. If it is not right in the first time, we have to redo it. Impact on the productivity. So I don't think it's a philosophical issue. It's a combination of all these factors. And there is no reason, frankly, there is no cultural reason or nothing, the genes of one country or the other to say we are condemned to be less productive than the others. Let us take all these points one by one, and accountability. The point about the Harvard, MIT comments, I mean, it's a very important, but I don't think I can add a lot to what they have said.
Okay. I'd like to take some questions further down the room because we've taken a lot from the front, and I know there's some hands at the back. So the gentleman here.
Hi, I'm Rafael Barreto. I'm studying A-levels. Do you think that technology in storing energy generated from power stations is an important issue nowadays, or if it isn't, what is?
Sorry, what is your question? At the beginning, I missed the first point.
Technology in storing energy.
Storage.
Yes.
Storage. Sorry.
Do you think that that's an important issue now, or
it has always been, because electricity. Simple comment. It's very difficult to store, so it is a big issue.
what would
I have been working in hydro, as you know, and in the 70s in France we built a lot of pumped storage power station, which was very successful and is still very successful. There is one in Britain, in Norway, which is working well. So storage has always been for electricity in kind of dreams of the engineers to do it. Now, the new challenges is the question of the batteries. Okay, so as I have said, my colleagues in EDF Energy are building the European largest energy storage battery. Where? In West Burton, very close to our coal and CCGT power plants, which is interesting because I like always the idea that old and new technology can bring people together. It is, however, for one single purpose, which is to be able to respond to national grid demands to bring back 49 megawatt in 1 second. So it's not really a daily, weekly, or monthly battery. Today, large-scale batteries for a week, even more, several weeks or months, are not commercially available. What is very important is to continue, and we invest in R&D a lot on these matters to find a solution. But what sometimes I am hearing about the magic solution, solar and renewable, both intermittent, the intermittency issue is fixed with the batteries. And therefore we can get rid of base load. Maybe one day. Some would say not before 2040, 2050. And it's not yet sure. So I think as the responsible people, we need to work on it, to develop, invest in R&D, but certainly not betting, gambling on it, if you want to keep the lights on. So that's a simple answer to my point. But it is typical of things which will evolve. I have no doubt about that. And there are everywhere in the world, in China, in US, here, people working on batteries. And I wish it succeeds.
Thank you. Question here? Oh, and then we'll take one at the back.
Edmund Booth, structural engineer. Persuading a diverse and inclusive group of intelligent youngsters that engineering is a fantastic career which has wonderful challenges, is exciting and is useful to society is in principle not difficult at all. Persuading a wider public that what we do is useful to them is much harder. The people, many people, including professionals for sure, will see their jobs changing, disappear because of digitization. You you referred to Small is Beautiful, and it's a book about economics, and the subtitle of that was Economics as if People Mattered. Persuading engineers that they must carry out their profession as if people mattered is difficult, and I wonder if you have any thoughts on that.
Well, of course it's difficult, but there is a lot of things which are difficult, not only this one. I'm sorry, I'm going to repeat a bit what I said. Our society needs a sense of purpose. And the more things are changing, and they're changing very rapidly, the more the sense of purpose, what is to be a force for good, is critical. I've said that digital transformation is happening and it's transforming. It's a lot of positives. And I was discussing with a doctor a couple of days ago how artificial intelligence will have a huge impact on their jobs for the good. So it's not about saying we should not welcome that. And at the same time, I think the engineers have to be part of this debate. There are a lot of ethical issues. So the consequence of the jobs of artificial intelligence is one of them. But more fundamentally, how far it will replace human. And the idea that human will be replaced means that the world will not be longer viable. So how to organize a real dialogue within the society between engineers, academics, philosophers, religions, politicians is fundamental. And I think it is missing. I have said we need an innovative regulation for innovation. But we need not to have it in 10 years when it will be too late. And we have the same, in my view, much larger impact type of crisis that we had in 2007 and 2008, where the lack of regulation in the financial industry created this debacle. And then you have to fix a problem that you have not addressed early enough. So innovation requires innovative innovation. Mm-hmm. And all this question of artificial intelligence, digital, it should be people thinking about how to regulate it in a way that it is making our societies tomorrow for children and grandchildren a place where they can flourish as human beings. Politicians are totally sorry if there are politicians in the room. They cannot fix everything. They need to be helped. And I think we should have a duty to encourage a form of regulation of this innovation.
Well, you're raising really interesting points here, and we could spend all evening discussing them, because I know there are lots of hands up with people wanting to ask questions. And you're absolutely right. The real thought about how one regulates, how one plans, and plans the workforce and through life training and reskilling to be ready to face this very flexible technology-led future that you're describing. Yeah. These are big issues that a society needs to address, and things that academies like ours really welcome engagement with. That we bring people together across disciplines to discuss and study exactly these issues. But right now, we have a very pressing issue, and that is that there are some drinks waiting for people downstairs. So although we could go on all night, I'm afraid I have to draw these questions to a close. But Vincent, thank you very much for a very thought-provoking and interesting lecture this evening. Well done.